Hello, everyone. Thanks a lot for coming and stopping for this talk. Um, my name is Clifano Subagio. I'm at Clifano on various social media, GitHub and Twitter. And I'm a senior consultant at Shine Solutions in Australia. I've been a Jenkins user since 2007. It was called Hudson back then, and I've been a on and off contributor since 2008. Today, I'm going to talk about adding voice capability to Jenkins. So that's how you trigger Jenkins through voice. Why voice? I was actually one of the people who thought that voice would be slower to use compared to, like, why do you want to talk to a piece of software when you can just type it out or click buttons and that will just happen so quickly? So that's what I thought before I had a son. So my son is now 2 years old, and when I'm driving in a car in a real traffic, and he started screaming, and he wants to listen to a children's song. And so I was under pressure. Here, there's a truck there, there's a bus there. And he was just screaming, wanting to play Thomas and Friends children's song. And ideally, I should tell him to, hey, please wait until we reach home. But obviously, he's not fully programmed yet. He's 2 years old. So I thought of reaching my phone, but I don't know if it's the same case here, but in Australia, it's illegal to even hold the phone when the car is moving. Is it actually illegal here to use your phone? Okay, so because the bus driver that took me from the airport actually used the phone while speeding and then trying to pull a cable, try to charge the phone. So that was an introduction. So I was actually really grateful that I could say, hey, Google, play Thomas the Tank Engine theme song on YouTube. And it just recognized my voice and then play the song on YouTube for my son in the car. So that really changed my thinking. Hey, it's not just always text and buttons, because in certain circumstances, you might actually need voice. And actually think about my aging parents as well. At one point, they might not be able to type using the keyboard. And maybe voice will be an alternative to that. So, so this talk is really about my effort of adding voice capability to Jenkins. So if you look back to the past, humans have always wanted to talk to machines. And here's an example, right? Captain Jean-Luc Picard talking to a spacecraft. So when I was little, I started watching Star Trek at the Next Generation series. And one thing that really made me think about this image here is that he's actually not looking at the screen. He's just talking to the ship. And the whole spacecraft is actually a voice interface. He can talk to the ship from anywhere, the wall, the floor, the ceiling. And maybe that's the future where we're heading. But yeah, so Captain Picard here is recording his captain's log, right? So captain's log number 1234. And he's just talking. He doesn't have to type. He doesn't have to look at the screen. And the next example is, here's Michael Knight talking to a car. So I don't know if many of you knows about the Knight Rider TV series, right? So this is Michael Knight, that's the character. He's talking to Kit, the name of the car. And this came from the 90s. And if you look at the picture on the right, he's talking to the car from his watch. So look at today, right? Smartwatch. You're probably talking to Siri through your Apple Watch. And this is from the 90s. And on the left, he's actually playing Atari games in the car. And that's an Atari joystick. And lo and behold, a few weeks ago, Elon actually announced, right, they're adding Atari games to Tesla. So talking about the 90s predicting 2018. It's quite accurate. So maybe in the future, we'll be talking to the wall, the ceiling, and the floor. And last but not least, for the younger generation, Silicon Valley, Jen Yang talking to a fridge. So this is when he bought a smart fridge, and Guilford actually hacked the fridge. So humans have always wanted to talk to machine, to a spacecraft, to a car, to a fridge. And I have always wanted to talk to Jenkins. So here's a sneak peek on how I tried to do it in 2012. So 2012 was way before the era of voice assistants, right?
Vicky, open Jenkins. Vicky, open Jenkins.
Open Jenkins.
So this is just showing the dashboard.
Vicky, build Bob. Vicky, build Bob. Vicky, build Bob.
Build Bob.
And that's building a job called Bob. And so I click on the executor, the console indicator, and showing that's actually building
Vicky,
the job.
configure system. Vicky, configure system.
Configure system.
All right, so that's just simply opening the configuration page. But you get the idea, right? So this is really sending voice command to Jenkins. So now I'm going to switch to the laptop. So the video just now showed a really simple thing. I was talking to Jenkins on a Firefox browser via a MacBook in 2012. So it was using a piece of technology called speakable items. So I don't know if you know, but it actually has been around for decades. Pretty sure it was there from the 80s. It's really simple. It pretty much maps out voice input into a command. So in my case, I used the trigger word Vicky. That's from the movie I, Robot. And when the MacBook listens that trigger word, then it captures the rest of the voice command, voice input as a command. So the command could be open Jenkins, and then that opens up a browser with the Jenkins URL. The file format itself is just an XML called plist. And it's really simple. There is no training capability, so it's just straight away voice input, command, voice input, command. And the quality is actually not that great as well. It is known to not filtering out the background noises well enough. So that's why you notice me repeating the commands several times. So the question is, can we do better in 2018, now that there is Siri, Cortana, Alexa, right, Google Assistant? And the answer is really yes, we can do better than that. But first, we need a programming interface for Jenkins. And that's what I did in 2017. So I was here last year presenting this talk called Bringing Jenkins Remote Access API to the Masses. That's where I presented a library called Swaggy Jenkins. That is an open API specification on top of Jenkins Remote Access API and Blue Ocean API. So the idea is that we can use this API specification to generate various API clients and libraries in 70+ technology stacks. And the goal is really to broaden out the possibility of integrating Jenkins with various technologies, because you just never know what devices will be created in the future and what programming languages that those devices will actually support. Now that we have the easy programming interface, we need the voice interface. And I had a look around at the options out there. And this is what I ended up with. This is the architecture. I'm going to use a Google Assistant and Google Home as the example device, but it's not really limited to just Google product. I'm not affiliated to Google but in any way. DialogFlow will be the natural language processing layer. DialogFlow also supports Alexa, Slack, and Facebook Messenger integration. So it really opens up the possibility of not just voice ops, but also chat ops using the same solution. So from the devices becomes the voice interface, right? So that's where I put in the voice and text input. And the Dialogflow becomes what I call an agent. This agent is then processing the language input. And then the next layer, that's a Google Cloud Functions logo there. The Cloud Functions becomes the middleware layer. It processes the commands that comes from the voice input and then translate that to API calls to Jenkins. And this is where I use the API client that was generated from the Open API specification. So I have a backup video here if the demo fails horribly. I recorded that in my backyard. But let's try, well, let's see if the computing god is going to bless this demo or not.
Here's some results from the web.
Can you hear that? Okay. Hey, Google, let me talk to Convo Jenkins.
Sure, here's the test version of Convo Jenkins.
G'day mate, I am Jenkins. How can I help you?
So that's the greeting. So I put in, because my phone is, I come from Australia, my phone has an ENAU locale. So I put in local flavor, right? Good day, mate, instead of just a normal hello. So we can define different greetings in various languages. So let's take it up a notch. Actually, let's open up the, whoops, oh, it's probably locked down. Oh, I was going to switch to my Jenkins instance, but probably the display is locked down. Build job, deploy application to production.
Job deploy application to production has been added to the queue.
So I was going to show you that the Jenkins screen will show that the job is being added to the queue, and it's actually building.
Sorry, I do not understand what you said.
Yeah.
Could you perhaps say that again?
So that's called a fallback. When Google Assistant doesn't understand what I was saying, then you can define a fallback. So the fallback in this case, it's asking, could you please say that again? I do not understand what you're saying. Let's try some more examples. What's your current version?
I am on version 2.121.3.
So that's retrieved from the sending a head request to Jenkins and getting the version number in return. So that can be expanded in the future. So one of my colleagues who's really administering Jenkins, one of the things that he religiously checks every day is actually, is there a newer version of Jenkins? So that can be expanded into, hey Jenkins, are you out of date? Can you upgrade yourself? Right? So that's just an idea. How many executors do you have?
I have 2 executors.
Right. So that's just to give some example of what can be done through the voice interface. So essentially, what is available through Remote Access API and Blue Ocean API. So in my mind, so this hasn't been implemented yet, but we can check the queue size. Is there any failed jobs? Is there any stock jobs? Is there anything that a human actually needs to do for the Jenkins interface? Or can that be identified as something that Jenkins can just self-heal? So what happened just then with the voice input when I told Jenkins to build a job? So here we have, starting from the left, Jenkins, and then Cloud Functions layer. The mini green icon there is the OpenAPI logo. And then the next layer is DialogFlow, and then a device, and then me, the human. So the first input is a voice command, right? So build job ABC. So Google Assistant through Google Action there, that translates that voice input into a structured data. So in this case, it is just a JSON file saying that the input is voice, and the text is build job ABC. DialogFlow, being the natural language processing layer, it translates that input into command. So it knows that, let's say, the input voice is build job ABC. It then knows to parse that ABC as the job name parameter. And this can be defined flexibly, as I'm going to show you later in the specification demo. And then the middleware through Cloud Functions that essentially sends a HTTP post through /job/job_name/build. So this is just a simple example. Jenkins then responds with 200 OK. And then it responds with a payload saying this is a text-to-speech response, and the text is job ABC has been added to the queue. DialogFlow will then pass the payload to something that Google Action actually understands. It's again saying it's a text-to-speech with the corresponding response. So this is then translated by the device into really voice saying the job has been added to the queue. And so this is what happened on every voice input that was provided. And I built this thing called Convo, and there's a Convo Jenkins implementation of it. It's pretty much just a Node.js library for voice and text conversation. It is specification-based. Really took the inspiration from OpenAPI. So the idea is that you can specify conversations and then map it to an API backend. It generates a DialogFlow agent and also an OpenAPI Cloud Functions middleware to fill in the components within the architecture. So essentially, it's mapping the voice input to the OpenAPI call. And the smarts really lives with the DialogFlow layer because it supports multiple languages, multiple devices, and multiple messaging applications as well. And it's available on GitHub. Now, what does it mean by conversation specification in YAML? So let's have a look. Other than the conversations, the specification actually defines some metadata as well, and they're pretty much identical to OpenAPI, if you're familiar with OpenAPI or Swagger. So I'm just going to jump to the conversation layer. So on the left here, I define a set of greeting replies. So this is what Jenkins will say, and you can specify, let's say in English, it says, hello, I am Jenkins, how can I help you? But then in the ENAU locale, I'll just say, good day, I'm Jenkins, how can I help you? And German version is Guten Tag, ich bin Jenkins. Does anyone here speak German? Oh, that's a good one. Yes, so you can correct my translation here through Google Translate. Does anyone here speak Japanese by any chance? No? OK. Yeah, and the other one is Indonesian. Right, so on the right side, it defines the unknowns. So the unknowns are the fallbacks. So how should Jenkins respond if the voice input is not understood? And for the example of the queries, so this is a conversation for finding out the current version. So the messages section define how this command can be triggered. So there could be many ways to trigger the same command, right? So I can ask, what's your current version? Or I can say, tell me what version is installed. So the more messages, the more sentences we add for this command, the better the dialog flow becomes. So this is the training part of the DialogFlow NLP layer. And obviously, this will differ between languages. And then, on the right side, it defines for those given commands, for those given inputs, how can I reply? How can Jenkins reply? And the idea here is that you can define a number of ways of replying to the same command. Because if you just define one, it becomes robotic, right? Jenkins, do this, and then job has been done. So that's a bit boring. So there is that you can specify different ways of responding, and then we can randomly pick one of the replies from the list. And then for this example here, let's say the first reply is my current version is, and the syntax here is headers.xjenkins. That pretty much retrieves the version number from the headers object, and the key value is the xjenkins, so that holds the version number. And it allows the user to easily specify which part of the data payload do you want to use as part of the reply conversation. So Jenkins will just say the word. And because this is parameterized, it's really easy. You don't have to worry about positioning. So in the English version, maybe the version value is defined at the end. But if you look at the Japanese version, it's not actually at the end. It's before the end. And similar to the first example, so this is about building a job. And this is where you can define the position of the parameter in your voice input. So for example, here, the build job, it says build job with the job name parameter. So that defines, if you say build job ABC, then it will know that the ABC is actually the job name. And that's how DialogFlow parse the voice input into a parameter. So this can be actually made more complex if you have more parameters. So an example could be build job ABC, but allow a delay of 30 seconds. So that's also possible because the remote access API allows a delay in seconds. And Jenkins can be multilingual too, as defined in the specification. I wonder if this is gonna work. Oh, problem. Oh, to the guy who speaks German, do you mind coming up on stage? I'm going to do a demo, but I totally butchered German language, I'm sorry, in one of the videos, so I thought maybe let's bring in a real person who can speak German. Hi, what's your name? Stefan. Nice to meet you. So let's try. This can fail horribly as well, because I don't know whether the voice input will work or not with this display. So let's try this. Do you mind trying saying that? Sorry. Oh, so 1, 2, 3. Okay, 1, 2, 3.
Mit Convo Jenkins sprechen. Dann should Connor.
Google isn't doing really well on that one. Okay, let's just click it. Okay, so there's no audio, but it's actually supposed to be saying well, I don't know if you can you read that?
Gerne. Hier hier ist die Testversion von Convo Jenkins. Guten Tag, ich bin Jenkins.
So that's Jenkins greeting in German. So can you say, can you ask, what's your current version? Just click this.
Was ist die aktuelle Version?
Oh, can you read that?
Ich bin auf Version 2.121.3.
Ah, right, good, thank you. So this is actually the right translation, right?
Yeah, that's pretty good.
All right, thank you. Thanks a lot, Stefan. So that's Convo Jenkins working in German with a real German speaker. I didn't know Stefan before. We just met just now. Yeah, so it's working. I actually had videos for Japanese and Indonesian language as well. And that's just because I actually grew up in, and this is the reason why I chose Google Assistant over the other options at present. I grew up in Indonesia until my teenage years. I moved to Australia since then. But when I grew up, I learned American English from NBA games commentaries. So I still remember the first one, Allen Iverson, Philly games. And I grew up trying to speak to my grandma in Chinese, which failed horribly. And then when I moved to Australia, and I thought, this is not English. I couldn't even understand whatever they were saying on TV. And the result out of all that is my confused accent. And out of Siri, Alexa, Cortana, and Google Assistant, I must say Google Assistant understood me the best so far. So I don't know for what reason, but it works. So I'm going to try Japanese as well. And so we're definitely sure there is no Japanese native speaker, right? Or anyone who knows Japanese at all? No? So I did one semester of Japanese, so let's give it a try. So I triggered Convo Jenkins through Japanese, which I didn't know how. So I'm going to try a similar command. What's your current version? In Japanese. So I have my cheat sheet here. Anata no genzai no bajon wa nani desu ka? All right, so there's no audio, but if you, I don't know if you can see it here. So this is exactly here. I can't read that, but that's 2.121.3. So that's the version in Japanese. So yeah, so that's working in Japanese. Let's switch back to the slide deck. So the example with talking in oh, sorry. You seem to be having a... all right. Okay.
Bicara dengan Convo Jenkins. Bicara dengan Convo Jenkins.
Sip, saya hubungkan ke versi percobaan dari Convo Jenkins.
Jalankan pekerjaan ABC. Jalankan pekerjaan ABC.
Right. So at the beginning there, I learned that so I called the project Convo Jenkins. And it's actually hard to trigger it in the same language, in multiple languages for the same application. So I tried calling it Convo Jenkins, and that's probably similar to what Stefan was trying to do in German. And Google just didn't get it. And I tried a slightly different pronunciation because ABC in Indonesian is similar to the Dutch, ABC. So I called it Convo Jenkins, and it still didn't get it. So that's one of the interesting findings I had about this, the various language support. And also for the demo, I actually triggered a job to build, but the job is called ABC. And that's because calling deploy application to production that's not parsed the same way in multiple languages as well. So what are the lessons learned out of all this? So the job names, like you have to be, probably, you want to optimize the job names to suit your language. So I tried to be smart earlier on with the demo, and I have a job called Release the Kraken, right? And I tried it so many ways. I asked my colleagues, Australian English, American English, no one just get it. Release the Kraken, at best, was translated to grill Easter cracking. And that's probably something for Google to improve in the future. So yeah, so lesson number 1, optimize the job names. And then the next one is optimize the project names. So I found out that Jenkins itself cannot be used. And that's probably because Jenkins has a trademark against it. So I ended up calling it Convo Jenkins. But then again, that couldn't be understood easily in multiple languages. So perhaps we should call it a different name for different language that you want to use as the primary language. Some more lessons. So yeah, optimize for the language, not just the job names, but also the phrases. So the specification allows us to easily just keep adding more and more phrases and train the AI on DialogFlow, the machine learning on DialogFlow with so many more inputs. The one phrase, the one sentence example for the message alone, so let's say build job, that's actually good enough so that Google Assistant DialogFlow can understand it when I call it build a job or build a job named something. And they're all mapped to build job. But the idea is that if you add more, then it will understand more. So maybe some people call it run the job or run the task, right? So there are so many combinations that can be added. Error handling. So at the moment, if a job doesn't exist, it will just read the message within the error object, within the API client. And as we all know, most programming error messages will be in English. So this wouldn't make sense in other languages. So my plan is to also allow error configuration for, so let's say we can map 404 into various languages of saying the job doesn't exist. And as for Convo itself, even though it's using DialogFlow and Cloud Functions for the middleware, it's actually possible to use it without any open API backend. So just do anything because it allows code injection and that will be in Node.js. And what's the most important lesson out of this small experimentation? So I learned that web API is often designed for machines. So I don't know if anyone has seen, so I've seen one endpoint with, and I'm not going to say which enterprise product it is, one endpoint with 100 parameters possible on the interface. So that's really saying that the web API is really designed for machines. It's just like even though it shouldn't, it should be designed with experience in mind, but many times endpoints are actually designed for machines to optimize, obviously, like call the same endpoint with 1,000 possible permutations of the parameters, fair enough. But that's not what humans interact with machines. So I was thinking conversation API must be designed for humans. Multiple ways of messages can be mapped to the same endpoint, but there is no one human who will want to go through 100 parameters. So out of those 100 parameters, and probably the permutations of them, maybe, I don't know, 20 most used combinations can be extracted into conversations. So there needs to be a distinction between conversation and the capability within the machine itself. And this is exactly what my colleague said when I told him, hey, I built this thing that you can talk to Jenkins through voice. And he said, now I can be the weird guy in the corner talking to his Jenkins server. So everyone was laughing a bit. But I laughed too, but I thought it might be weird for now, but maybe it's common. It's going to be common in the future. Maybe the way we interact with machines will actually change. But yeah, I don't know, maybe. So looking at the progression from Jian Yang talking to a fridge, Michael Knight talking to a car, which is now reality. Well, you can talk to your car if you want to. And Captain Picard talking to a spacecraft. Maybe in the future we'll just be talking to this room, right? So we don't know, maybe. So contributions are welcome. If anyone speaks Klingon, please, because I don't. There are so many languages that we can add. We can make Jenkins more conversation-able. And yeah, the URL is github.com/clifano/convo-jenkins. Is there any questions? Right, if there is none, thank you very much. I hope you enjoy the presentation, and that's talking with Jenkins, having a talk with Jenkins. I'll be around the conference if anyone wants to have a chat. Thank you. Thanks a lot, everyone, for coming. And thank you, Stefan,